Elastic and inelastic collisions. Collisions are classified into two classes, elastic and inelastic collisions. When bodies collide, before collision, the bodies will have kinetic energy. Both the bodies may have kinetic energy or one body will have kinetic energy. That means one body will be moving. Then it will have kinetic energy. This kinetic energy, the total kinetic energy remains the same after collision. Such collisions are called elastic collisions. Elastic collisions. If the total kinetic energy of the bodies, changes after collision, generally decreases, it cannot increase, decreases, then it is called, during explosion the kinetic energy increases, during explosion the kinetic energy increases, but if the moving bodies collide, the kinetic energy decreases. Such collisions are called inelastic collisions. Inelastic collisions. Now, mathematically, we represent elastic collisions as follows. Half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. That means there are two bodies of masses m1 and m2. If they are moving with velocities u1 and u2, we know that the kinetic energy of a body is half mv square. So, the kinetic energy of first body is half m1 u1 square and the kinetic energy of the second body is half m2 u2 square. So, the total kinetic energy before collision is half m1 u1 square plus half m2 u2 square. After collision, if the velocity of the first body becomes v1 and that of the second body becomes v2, then the total kinetic energy after collision is half m1 v1 square plus half m2 v2 square. If half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square, such a collision is known as elastic collision. Before collision, total kinetic energy is half m1 u1 square plus half m2 u2 square. After collision, the kinetic energy, total kinetic energy is half m1 v1 square plus half m2 v2 square. If these two quantities are equal, it is called elastic. If these two quantities are not equal, it is called inelastic collision. Inelastic collision. In both the type of collisions, momentum is conserved. Momentum is conserved. That is, the total momentum before collision is equal to the total momentum after collision. We know that mv is momentum, mass into velocity. So, the momentum of first body is m1 u1. The momentum of the second body is m2 u2. The total momentum before collision is m1 u1 plus m2 u2. The total momentum before collision is m1 u1 plus m2 u2. The total momentum after collision is m1 v1 plus m2 v2. m1 v1 plus m2 v2. So, the total momentum before collision is equal to the total momentum after collision in both the cases. That is, in the case of elastic collision and in the case of inelastic collision. The total momentum remains constant.